When it comes to DSA interviews, sliding window maximum is one of the most favorite question of these big tech companies and even a lot of small and mid-sized companies as well. So that is why in this DSA in JavaScript video, we're going to discuss two ways that you can write an algorithm for this question. Alright, so the question says that we've been given an array of integers nums and there's a sliding window of size k, which is moving from very left of the array to the very right, and you can only see the k numbers in the window. Each time the sliding window moves right by one direction. So what does a window mean? So window is basically this number 3 over here, the value of k, and window means that only 3 elements are gonna be inside of this window at a time, and this will move by one step forward. So first this was the window, then this was the window, then this was the window, and so on. And each time we are supposed to calculate the maximum element inside of a particular window and create an array out of it. So let's say for the first window, this is going to be 3. So I'll say 3. Now for the second window, that is this one, it's going to be 3 again. So 3, okay. For the third window, it's going to be 5. For the fourth window, it's again going to be 5. For the sixth window, this you can see the 6 is maximum now. So 6. And then for the last window, 7 is going to be the maximum. So this is going to be our final answer or the final output. Alright, so first of all, let's discuss the brute force or the naive solution, because that is what we're supposed to do in an interview before we move on to an optimized solution. Because if you just straight up go for an optimized solution, you might miss out some use cases as well. So I'm going to create a function over here called max sliding window naive. And I'm going to create a function, anonymous function with parameters of nums and k. So nums will be the actual nums array and k will be the size of our window. Now inside of it, I'm going to declare a variable called result and initialize it to empty. Now this result variable is to store the maximum elements on each window. And then I'm going to declare a variable called n, and I'm just going to store the length of our array so that we don't have to write nums.length every time. Now first of all, what we are supposed to do is we're supposed to create every single combination of this window that we can. So if the size of window is 3, so we're gonna go to this window, then this window, then this window, then this window, and so on, and loop through each and every window to check maximum in that window. So I'm gonna create a for loop over here for iterating through this array at least once. So this first for loop will iterate through all of these elements, and we're gonna leave 3 elements at the last because we're gonna start from here and then we're gonna iterate through the size of window. So this, then this, so this will go till over here, and after this we won't have enough elements for completing the size of window, right? So we're gonna just iterate through this much. So I equals 0, I less than equals to n minus k. So n is the size of the array and k is the size of the window, so that will lead us up until this point, then I plus plus. Now inside of it, I'm going to declare a variable called max, and max will hold the value of the first elements. So nums of I. So what we're doing over here is we're telling that let's assume that the current max element in this window is I over here. That is this first element, right? So that is what we've done over here. And after that, we're going to start looping through this window, our first window. So for that, we're going to create a for loop. J equals 1, j less than k, and j plus plus. And now inside of it, what we're supposed to do, we're looping through all of these elements, right? Now we're gonna take each and every element and compare to this max variable over here. And if you notice, I've started it from 1 because we already had the max for this 1 over here. So we're gonna ignore that. We're not gonna compare it with itself, right? So j equals 1, j less than k, and j plus plus. And now inside of it, I'm gonna say if the current element, that is nums of I plus j, is more than max. If that is the case, if this current j element is more than max, then we're gonna say max equals nums of j plus I. That's it. That is all you have to do. And in the end of each and every for iteration, the inner for iteration, you're gonna get a max element for that particular window. And after we get that, we're just simply gonna say result dot push and push it inside of it. So push max, and this will populate our result array, which is going to be our final output. So then we're gonna say return result. That's it. That is all we had to do for this solution. And you see, creating a naive solution makes our job so much easier. At least now we have a solution to show to our interviewer, right? So let's try to run this. I'm gonna say, okay, let me just do console log. Then I'm gonna call it inside of over here, and I'll provide it with this nums array and the size of our window, that is 3. Let's try to run this. I'm gonna open my terminal, and then I will say node sliding window maximum. Okay, let's see what do we get. Okay, let's compare it with our output. Yep, that is exactly what we were expecting. Awesome. So let's take this result over here and try to run it on LeetCode. If you're preparing for your front-end interview and you would like me to help you in your front-end interview preparation, just click the link in the description down below and book a one-on-one call with me. We're going to discuss tips, tricks. I'm going to give you a lot of resources. I'm going to design a proper roadmap tailored to your situation, which is going to help you out a lot in your front-end interview preparation. So click the link in the description down below and book a one-on-one call with me. Let's try to run this. All right, this ran successfully. Let's submit this. Uh-oh, we have reached time limit. So this algorithm was not good enough to clear the test cases of LeetCode. So you see, this one, it took a lot of time. So, okay, fine. Let's go and optimize our problem. But first, let's understand what was the time complexity of this problem that this was not able to pass the test cases. Let's understand that. So as you can see over here, this loop runs for n minus k. Okay, so the time complexity for this loop is O of n minus k, which we can assume is n, because this time complexity is a constant, right? And inside of it, this runs from 1 to k. So the time complexity of this one is O of k, which again we can assume is a constant, right? So our final time complexity is gonna be O of n multiplied by k, which we assume is O n multiplied by k, which we can say is O of n square, if we consider both of them to be a constant, right? So this is an exponential time complexity. It's a very bad time complexity. That is why our algorithm failed to run on LeetCode. And when it comes to our space complexity, it is gonna be O of n, because as you can see, we are creating one variable over here for the array, and then we are populating that variable at the very end. So this is gonna be O of n. All right, now let's go on and understand how we can optimize this algorithm. Alright, well, such an important algorithm has to be explained by Algo Agarwal. So let's understand how you can do an optimized version of sliding window maximum visually. So we have our nums array as this, and we have a window size of 3. And as you can see, I have written a rough algorithm over here on what we are going to do. So we're going to need two things over here. First is going to be a result array, which is going to contain our final result. And the other is going to be a DQ array. Now, what is a DQ array? So DQ array, basically, let's say for example, if I write an array over here, 5, 7, 8, right? Now in a normal queue, you can add an element from one side and remove from the other side. So for example, you can push an element from this side and remove from this side. But in a DQ or a doubly ended queue, you can do this from the other side as well. You can add it from here and remove it from here as well. So basically on both sides you can add and remove, and this side as well you can add and remove. So this is what a DQ is. And in our case, our size of our DQ will be the same as the size of our window, which will help us calculate the maximum element for each and every window size. So let's see how we're gonna do that. First of all, let me just create a DQ over here. And our first element is 1. We're gonna loop through this complete array over here, right? So if I say for loop, and this for loop is going to run from 0th index to nums dot length. And all of these operations are gonna happen inside of this loop. Now we're gonna take our first element, which is 1 over here, right? So I will add this 1 inside of our DQ. Fine. Let's take our second element over here, which is going to be 3. Now before adding 3 inside of this DQ, so first of all, as I already told you that DQ, our size of our DQ is only 3. So we have to be careful on what we are going to add inside of our DQ, right? So we are going to add 3 now. But first we will check, is there some element inside of this array, or the last element of this array, is this more than the current element? So is 1 more than 3? No, it's not. So we're not gonna keep 1, we're gonna remove 1 from over here. And we are only going to keep 3, right? Because our ultimate goal is to calculate the maximum for each and every window, right? So for each window, it's better we keep the maximum element. That is what it makes sense, right? So yeah, that is what we're gonna do. So we have kept 3 over here, and our current window is this one, right? Now our next element, -1. Now it's gonna check again, is the element on the last, is it more than -1? No, it's not more than -1. So we can easily add that element over here. Now, as you can see, our window limit has reached. And I've added this condition over here as well. If the current element, which is I, if it's more than or equal to k-1, k-1 will be 2. 3 minus 1 will be 2. And our current element, which is 0, 1, 2. So 2 more than equals to 2. Yep, that is true. So what we're going to do, we're going to take first element of our DQ and add it to our results array. So our results array is over here and I'm going to add 3 to it. Now you might be thinking, what have I done over here? Why am I doing it just like this? So it's because inside of our DQ, we are not going to add the actual element. I'm rather going to add the index of that element. So if it's 3, so it's going to be actually 2 inside of this DQ. So in reality, this will look something like this. The index of 3 is 2 and for -1, it's 3. And why I'm doing that, I'll explain you just a minute when I go on to explain this code. Now, we're going to move on to our next element, which is going to be -3 over here, right? And automatically, if we are moving to our next element, then we have assumed that window has been moved from here to here. So now, -3, let's check. If the element at the last of this DQ, is it more than -3 or not? So we have third index, which is 0, 1, 2, 3. Oh, my bad. I have not written this properly. So it's not going to be 2 and 3. It's going to be 1 and 2. So 1, because third, the index of 3 is 1 and -1, it's 2. Right, now we're going to check the index 2 over here. In the index 2, it's -1, 0, 1, 2. So is -1 more than -3? Yep, it is. So we're not going to do anything and we're going to simply add -3 over here. And the index of -3 is 0, 1, 2, 3. Just like that. And again, since we have completed this operation and we have our maximum element inside of over here for this window as well. So again, we're going to add that. So at index 1, we have 3 again. So I'm going to add 3. Now I know it must be a little confusing for you to understand right now, but don't worry. As I explain this, you're going to understand eventually. Everyone has this problem with this question. In first go, they are not able to understand. Let me continue. So fine, our result array has been generated as such. Let's move to 5th. And we're going to assume that our window has also been moved. Now let's understand our code now. First of all, when we are supposed to add 5th inside of it, you can already see our window is completely formed and there is no other space to add 5 over here. So the only logical thing that is left to do is to remove 1 from over here, right? So that is what this piece of code is doing over here. So let's see. dq.length more than 0. Yep, it is more than 0. dq of 0, that is 1, is less than or equal to I minus k. Now what is I? So I right now is 0, 1, 2, 3, 4. So I is 4 minus, what is k? K is 3. 3. 4 minus 3 is equals to 1. And dq of 0 is also 1. So 1 is equal to less than or equal to 1, right? So if that is the case, we're going to run dq.shift. And as you already know, shift is used to remove the element from the front of the array, right? So that is exactly what we're going to do. I'm going to remove it from over here. So now our array looks something like this. Now let's move on to the next step. Now what we are supposed to do. Now we usually what we do is we check. Is the last element more than the current element? Is it the case? So let's see. Third index 0, 1, 2, 3, -3. It's not more than 5, right? So we're going to get rid of it. But where is it happening? Let's see our code. So inside of our code, we can see nums of dq.length. Okay, this is a little bit confusing. So let me see. dq.length. What is dq.length? 1, 2. The length is 2, right? So sorry, it's length -1. So 2 minus 1. So it's ultimately going to be 1, right? Now the first element of our DQ is what? So 0 and 1. So it's going to be 3 over here, right? So I'll remove this and I'll say it is, this value over here is 3. Now what is nums of 3? Nums of 3 is 0, 1, 2, 3, -3. So this is how we know what is the current element over here. Now we can compare. Is -3 less than nums of I? And you already know nums of I is 5, the current element, right? So is -3 less than 5? Yep, it is less than 5. So we're gonna get rid of it. So I'll just remove it from over here, right? So we have removed that from over here. Now again in our next step, since as you can see this is a while loop, it's gonna run until it gets false. So it's gonna again check for this element as well. For the second index, 0, 1, 2, minus 1, is minus 1 less than 5? Yep, it is less than 5. So I'm gonna get rid of that one as well. Great. And now we can successfully add 5. Now there's nothing remaining. So now whatever element that will be added over here is going to be the maximum for this window size, which is 5. So 0, 1, 2, 3, 4. 4. Right? So we've added 4th over here, and with this we can do result.push again, and 4th element is 5, so we can add it in our results array. Similarly, we're going to encounter 3. It's going to check, is it more than 5? No, it's not more than 5, so we can add it over here. So 5th element over here, and now again we're going to check which is the maximum in this window. It is 4, that is the value 5, so 5 added over here. Now our next element, 6, is 6 more than this last element? So 5th, 0, 1, 2, 3, 4, 5, which is 3rd. Is 3 more than 6? No, it's not more than 6. So that is when we will remove it. And it's going to compare with this one as well. Is it more than 5? No, it's not more than 5. So now we can add simply 6 over here, which is of index 0, 1, 2, 3, 4, 5, 6th. So 6th index. 6th index as well, and 6th value as well. So we've added 6 over here. And now again in this, which is the maximum? It's 6. Right? Now next is 7. Now 7 is going to check which is the element in the 6th index. In the 6th index we have 6 itself. So it's going to check, is it more than that? No, it's not. So I'm going to remove it, and I'm going to simply add 7 over here, which also happens to be in the 7th index. So 7 over here. Now again at the end of this loop, we've come over here, we've added 7, then we've come over here and we're going to add it inside of our results.push. So 7. And this is our final results array over here. So you see how easy this algorithm is. Now I know some of you might not have the complete clear picture at this moment, but don't worry. Roadside Coder is going to write the code now, and it's going to give his own explanation on how you can do this while writing code. Alright, now let's go on and see the code for this, and let's understand how we're gonna implement sliding window with DQ. Now, if you're enjoying this tutorial up until this point, open your Instagram app right now and search Roadside Coder and hit that follow button as hard as you can, because I'm very active on Instagram, and if you have any doubts, any queries, or just a normal message, you can ping me on Instagram for this. So go on, do it. I'm waiting. What? I'm being serious over here. Open your Instagram app right now and follow me there. Oh, you've already done it? Okay, let's move on with this video. So first of all, as you can already see, I've created a function over here that is going to take nums and the size of our window, just like previously. And inside of it, I'm going to take two variables. So one is going to be the result, which will obviously contain our final result, and other is going to be DQ, which will help us know the maximum element for that particular window. Now I'm going to run a for loop which will start from 0. So let I equals 0, and it's gonna go to nums dot length and I plus plus. Now this is what we're doing to iterate through the complete array. Now inside of it, what we're gonna do, so initially our DQ is empty, right? But let's say our DQ has something. So let me just let's take this example. And so this is our nums array, right? Let me just write nums, and similarly we're gonna have a DQ. So initially our DQ doesn't have anything. So we're going to store indexes in our DQ, right? Not the actual numbers. In our DQ, let's say we already had 0th index, first index. We have 2 over here. So we have added this complete window in our DQ, right? That's fine. Now let's say the value of I is -3. The current value of I is -3. Now we have to add this element inside of over here, -3. But we can't do that, right? Because maximum window size is 3, that is k. Right, so we have to remove this 0 from over here. So how will we do that? We're gonna say if DQ has something inside of it, that is DQ dot length is more than 0. Yeah, obviously. And DQ of 0th index. We're gonna check if this 0th index falls into our window or not. So DQ of 0 is less than equal to I minus k. Right? Let's understand what's going on. So DQ of 0 is the 0. Fine. And the current I, as I mentioned, was -3. That is 0, 1, 2, 3. Right. So 3 minus k, that is 3 minus 3 equals to 0. And is 0 equals to 0? Yep, it is. So we're gonna remove that and add -3. But let's say if it was -1. So if let's say our window was formed this much only. right? Now the current element is -1. That is the value of I now is 0, 1, 2, right? Now dq of 0 is less than or equal to 2 minus 3, which will result in -1. So is 0 less than -1? No, it's not. So it's not gonna remove this element, and later on it's gonna go on to add that element if applicable. If this condition satisfies, I'm gonna simply say dq dot shift, and I'm gonna remove that element to make space for the next elements, right? Fine, one of our cases is handled. Now next, what we're gonna do, as we discussed in the visual explanation, if in our window already we have some elements which are smaller than the current element, then we obviously don't need that element. We don't need that element to stay in our window, so we're gonna remove that element. And we are forming our window such that the maximum element is at this position right over here, right? So that is what we're gonna do. I'm gonna add a while condition over here, while loop I mean, and I'm gonna say dq dot length. First I'm gonna check if the length is more than 0. That's the base condition for everything. And let me just write this real quick, then I'm gonna explain you what I've done over here. So let's say we have 0 already, that is 1 already in our dq, right? Fine. And now we're gonna add 3, but we noticed, okay, 3 is greater than 0th index, like 0th index is 1, right? So we noticed that, okay, 3 is greater than that, so we don't need this one. Why would we need that over here? So we're gonna remove that. We're gonna pop it, and we're gonna simply add the index of 3, that was 1, right? Similarly, we're gonna move forward. We're gonna say -1. Okay, is -1 greater than 3? No, it's not. So we're gonna add that over here because we are storing it in the decreasing fashion. So now we have completed this window. Now let's say if we moved forward, we are in this window over here, right? We already have 3, we already have -1. Now we're supposed to add -3. Let's say this was not -3. Let's say this was something like 7. Okay, now we're gonna compare. Is 7 greater than the last element that is kept over here, that is -1? Yep, it is greater than that. So I'm gonna remove that. We're not gonna need that, right? Now again, since it's a while loop, I'm gonna loop through all of the elements. So again, it's gonna check, is the last element, that is 3, is it greater than that? Yep, it is greater than that. So we're not gonna need that as well. So I'm gonna remove that, and now we're gonna add 7 to it. So 7 is 0, 1, 2, 3, third index, right? So that is what we are gonna do. And similarly, it's gonna move forward for all of these windows, and this is how we're gonna determine which is the maximum element inside of a single window. Great, so we have handled both of the situation. Now we can safely add our current element to our dq. So we can say dq dot push nums of I, or oh, sorry, not nums of I, because we are just storing the indexes, so just I. Now at this point, our window has started forming. So I'm gonna simply check if the current element is more than or equals to k minus 1. So we're simply checking over here, is our window completely formed? If it's completely formed, then I'll say result dot push to be nums of. So if you notice, our dq was forming in a decreasing order, right? So the first element will be the greatest. So simply we're gonna say nums of dq of 0th. So whatever element is in the 0th index, we're gonna consider that as the greatest for this particular window. So that is what we've done over here. And now after we are done with this for loop, we will have our result array formed, and we're gonna simply return result. And that's it. That is all we had to do this, right? Let me just remove this and try to run this. So I'm gonna take the same example. I'm just gonna comment that one out for now. And here we go. Let's open the terminal, run this. Awesome, we get the same output. Let's try to take this code and try to run it on LeetCode and see if this time around we actually get a solution or not. Paste it over here and run it. Okay, test successfully ran. Let's submit it. Amazing. Our solution beats 54.93% of the other solutions. But what is the time complexity and space complexity of this? So over here, if you noticed, we have just ran one single for loop over here, right? Which is going to be O of n, or nums, right? The length, let's say the length of nums is n. So I'm going to say O of n, right? This is the one for loop, the first for loop. And this is, in this loop, it's not necessarily that we are going to have all of the elements that are going to have all of the elements that are smaller than the current element. So this loop doesn't hold that much of a significant value, right? So in total, I would say our time complexity is O of n, right? And if you notice our space complexity, we are creating two variables over here. One of them is result and other is dq. So size of result will eventually be O of n and the size of dq will be 3. So it will be more like O of n plus 3 or k, which is both of them are constant, so I'm going to consider it as n. So the space complexity is also n. So yep, that is it for this video. If you haven't yet accessed our complete DSA with JavaScript series, click this card on right to access the complete playlist. And if you like this video, give this video a huge fat thumbs up and subscribe to the channel for more such awesome interview videos.